So let's say you got a couple kids and they're doing an experiment and they have to measure the speed of this ball bearing when it reaches the bottom of the ramp. They want to know how fast it's going. So when you think of how fast something is going, you probably tend to think in miles per hour because you're an American and that's how we learn speeds growing up. You might be thinking about it in feet per second, or maybe meters per second if you're in some other country, or who knows, you get some wacky unit like inches per day, maybe. No, probably not. That is kind of wacky. Anyway, what do you think they're going to measure it in? I guess that's my question. What would you measure it in? If you did this experiment and you were trying to measure it in miles per hour, think about this. If you're measuring a distance, say from here to here, are you going to measure that in miles? I would say probably not, because your answer would be 0.0000 something. So miles doesn't make much sense. Likewise, the time it takes to go from there to there, would you measure that in hours? Probably not, because it would be, 0.000 something hours. So I think what makes a lot more sense here would be to measure the speed in something per second. I'd prefer meters per second, but you could go feet per second. And then if you wanted to, then you could convert to miles per hour when you were done. So the converting is what this video is all about. So that's one reason why you would want to do it. I mean, I could think of other reasons why you would want to convert. Maybe you're driving from one country into another. You're going from the U.S. into Canada. You got miles per hour and then kilometers per hour. Or maybe something even more useful, like if you're going to measure a bunch of corn or grain, would you measure it by, probably not by the bag or by the bushel, maybe by the ton or the kiloton? So or maybe by the train car. I don't know. But the point is that you're going to have to convert stuff. I remember one time when I was at a doctor's office and a nurse was studying up for a quiz. She must have had to take some classes or something, and she was converting milliliters to liters. And I overheard her, and we started talking about the converting. And she said, "Oh yeah, we have to do that kind of stuff all the time here." So converting is something that you need to know how to do. Okay, so that is why. Now let's do a quick math review. Okay, so I'm going to review a few rules. How about I write it like this? Rule number 1. And rule number 1 is, why did I write it like that? There, that's a little better. Okay, so if you have some number and you multiply it by 1, you get that same number. Like 6 times 1 is 6. No big deal. Rule number 2. If you have some number and you divide it by 1, you still get that same number. So 4 divided by 1 is still 4. Once again, no big deal. Rule number 3. What if you take some number and divide it by the same number, divide it by itself? You don't get that number again. What you get is 1, because that number goes into itself one time. So if we have 95 divided by 95, we don't get 95, we get 1. And even more to the point, you'll see how this relates in a minute, but let's just say I had 7 times 95 over 95. What would my answer be? Well, it's a combination of a couple of the rules here. It's a combination of what? This rule and this rule. 95 divided by 95 is actually just 1, right? So 7 is a number times 1, you just get the number. So 7 times 95 over 95 is just 7. So what's the point? Why would I do that? Well, on your second quiz, it's called Other Conversions, you've got to be able to switch from one unit to another. And what you're going to do is you're going to take advantage of using these easy rules to switch those units. Just as an example, let's just say that I go to the grocery store in the morning and I I see all the donuts they've got, and I want to buy all the donuts. And let's say there's 85 donuts. And when they're figuring out how they're going to charge me on the cash register, it rings them up as dozens. So when I take my 85 donuts up to the cashier, I want to know how many dozen that is. Okay, so I need to be able to convert those two. Now, some of you out there with amazing common sense skills, you're like, okay, this is an easy problem. It's going to be 85 divided by 12. Because if I did 85 times 12, I'd get this wacky huge number. And I know it's not that wacky huge number. It's got to be 85 divided by 12. Well, being able to convert, getting ready for this quiz, is what this is all about. So let me show you what you do. You write this down. You go 85 donuts. I'm just going to say 85D. I'm going to put it over 1 just to remind me that if I wanted to write it as a fraction, I could. I'm going to multiply this 85 donuts by a fraction that has donuts on the bottom. Why? I do that so that way it will cancel out. I've got donuts on top and bottom, and then they will cancel out. I'll come back to that in a minute. So I'm getting rid of donuts, and I'm going to dozen. Okay? So I know that 1 dozen of anything is 12 items. Donuts, bottle rockets, firecrackers, whatever. So I'm going to go 1 dozen is 12 donuts. So I go back and I go, all right, I've got donuts on top and bottom. That means my answer is going to be in dozen, which is what I want. That's a good thing. And then I do my math. 85 times 1 is 85. That's on top. And on bottom, 1 times 12 is 12. So to get my answer, all I have to do is go 85 divided by 12. 85 divide 12, and I get 7.083. I'm going to round that to 7.1. So 7.1. 7.1 what? Well, the donuts canceled because they were on top and bottom, and dozen is what was left, so 7.1 dozen. So when I go into the grocery store and get my 85 donuts, I'm going to get charged for 7.1 dozen. That's one problem. Let me do another one. Okay, my next problem. Let's just say that a doctor has prescribed some kind of medicine, and the medicine is measured in milliliters. So I'm going to say that every time you get a dose of this medicine, I'm going to say that it's 2.5 milliliters. Okay? And what I want to know is I want to know how many fluid ounces that is. Okay? So the first thing I've got to know is how many milliliters equal how many fluid ounces. So 1 fluid ounce is about 29.6 milliliters. So to do this problem then, I'm going to go, okay, I'm going to write my original number that I was given. I'm going to go 2.5 milliliters. I'm going to put that over 1, just to remind me that it's over 1. And then I'm going to multiply by a fraction that equals 1, kind of like I did here. So when I multiply by the fraction, it doesn't change the value of my answer. I'm just using it to change my unit. So I want to get rid of milliliters, so I'm going to have milliliters on bottom and fluid ounces on top. So let's see here. 1 fluid ounce, so the 1 goes by fluid ounce, 29.6 milliliters. And let's look at the units here. I've got milliliters on top and bottom, so they are going to cancel out. And then I'm left with fluid ounces, so that's going to be the answer of my unit. And just like last problem, I'm going to have 2.5 times 1, so my top is going to be a number. And then my bottom is going to be 1 times 29.6. And 2.5, so I'm going to have a little tiny answer here. So I'm going to have 2.5 divided by 29.6, and I'm going to round that to 0.08. Okay? So 0.08. So if you get injected with 2.5 milliliters of something, that's less than 1/10 of a fluid ounce. Okay, one last problem. Right before I got married, I knew I was never going to do it again, so I had to take the chance, and I had to buy myself a motorcycle that I wanted, and I got a Katana, and this motorcycle had an engine size of 36.61 cubic inches. What does that mean? That means that when all the pistons were down, this is how much space was above them. That might be more than you wanted to know, but oh well. Now, when I bought the motorcycle, it wasn't actually sold in cubic inches as the unit. When I bought it, it was measured in cubic centimeters. Just because when you buy motorcycles nowadays, it's all metric. But if I know that my engine has a displacement of 36.61 cubic inches, I wonder how many cubic centimeters that is. So to do this problem, I have to know how many cubic centimeters are how many cubic inches. How many of one equals how many of the other. So 1 cubic inch is 16.39 cubic centimeters. You'll also see this written as cc's. Anyway, so if this is how many of them equal, how many cubic inches equal how many cubic centimeters, how do I set up my problem? Well, what I do is I do the same as I did before. 36.61 cubic inches. I'm going to write that over 1 just to remind me that this is on top. I'm going to multiply it by a fraction. And I want to cancel out cubic inches, which is on top. So I'm going to write cubic inches on bottom. And I want cubic centimeters. So I want to put that on top. And then I'm going to fill in my numbers. I've got 1 cubic inch, so that's going to go here. And then I've got 16.39 cubic centimeters, so that is going to go here. So what math do I have to do? Well, the previous two problems I had to do some division. But this one, I'm just going to multiply across the top. It's going to be that times that divided by 1 times 1. Well, that's just 1. So all I really have to do is just multiply those two top numbers, this one and this one. So I'm going to go 36 point, whoops, let me go clear here. 36.61 times 16.39. 600 I get. Okay, so that means that my Katana that I bought right before I got married had an engine size of 600 cubic centimeters. How do I know it's cubic centimeters? Well, look, cubic inches on top and bottom, they cancel each other out, so cubic centimeters is all that's left. So this is how you get ready for the other conversions quiz.